Welcome to SAT 021. In this lesson, we'll be learning about the scatter plots. Scatter plots are the graphs that represent the relationship between two variables in a dataset. I will use a simple example to illustrate how scatter plots work. Suppose we have a class of 10 students, and their SAT score is listed below. I'm only showing 3 of them on this page because I don't want it to look too messy. Notice how each student has 2 factors, a reading score and a math score. That means we can graph this list of data onto a scatter plot. Take Sally, for example. Sally has a rating score of 140. So we find 140 on the horizontal axis, which is labeled as the rating score. And then we say that Sally has a math score of 200. So we find 200 on the y-axis, which is labeled as the math score. Now we have successfully graphed Sally on the scatter plot, which is x equals to 140, y equals to 200. And we can do the same thing for William, which has a rating score of 330 and a math score of 280. And if we graph every point onto the scatter plot, we could have something like this. We can also draw the best fit line on the scatter plot. The best fit line is a straight line that can help us to make an educated guess for values not in our dataset. For example, if someone has a rating score of 600, we first find the point on the line where x equals 600. And then we can estimate the y value for the point, which is approximately 590. So we can predict that for someone who has a rating score of 600, he or she should have a math score of about 590. We can also approximate the relationship between variable x and y by calculating the rate of change, which is equal to the slope of the best fit line. In our scatter plot here, we can choose 2 given points and use the slope formula rise over run, or changing y divided by changing x. We find the slope of the best fit line to be 0.9. That means for every increase of rating score, we'll estimate the math score will increase by 0.9 on average. Let's now try a practice problem. The scatter plot shows the yearly revenue of a certain grocery store. Notice we have a year on the horizontal axis and the revenue in thousands on the vertical axis. Part A, what is a reasonable estimate for the revenue of 2021? Well, we can use the best fit line to estimate the revenue of 2021. First, we locate 2021 on the horizontal axis. Okay. And then we find the y value of this corresponding point on the best fit line, which is 590. Part B, how much does the revenue increase each year on average? We want to know the rate of change of the yearly revenue, so we can use the slope of the best fit line to help us. Taking the points 2019 and 560, and then 2015 and 390, we can calculate the slope to be 33.5. And so the answer is 32.5 thousands per year. Okay, finally, part C. How many years have a yearly revenue between 300,000 to 400,000? Well, we can first locate the range of y values between 300,000 and 400,000 here. And we can see that there are 2 points that fall into this yellow region, 2013 and 2014. That means there are 2 years that have a yearly revenue in this range. Okay, that's it for this lesson. Hope it helped. Thank you for watching. See you next time.